So these rules, I'm going to go through these quickly. It's just a review. We did this with alkenes. The rules are that you first assign priority by atomic number. And so we have these four groups: fluorine, hydrogen, carbon, and nitrogen. And by atomic number, of course, hydrogen will be the low priority. The highest atomic number is fluorine, and then we go from fluorine to nitrogen to carbon. So, is the low priority group in the back? Yes, as drawn. So that's really nice. We don't have to rotate it to make the assignment. Is it the R or S enantiomer? Well, 1, 2, 3 is counterclockwise, so that will be the S. And the little note that I have at the bottom is that if you have isotopes, it will go by atomic mass. So if you had two isotopes of carbon, for instance, carbon-13 would have higher priority than carbon-12. Now, rule 2, we saw these rules before. That's if you have a tie. So you could have your chiral carbon, and let's say there's a carbon and a carbon. So that's a tie, right? So at the end of each of these is the chiral carbon, and these are the possible groups. Like, say we had any two of these groups on that chiral carbon, what would the high priority be? Well, what you do is you take this carbon and this carbon. Let's say I'm comparing those two. You play a game where there's 3 rounds. Each of those 2 carbons that I'm considering here initially have 3 hands to play. What is the best that the first one has? It's a bromine. What's the second best? H and then H. Now the next one, what's the best that it has? Chlorine. And then second best is chlorine. And the third best is hydrogen. Now you play this game 1 round at a time. So here we're comparing bromine to chlorine. Game over. Bromine is a higher atomic number. It wins. What about this carbon, the third one? What does it have? Carbon, carbon, and carbon. And the first atom off of that initial carbon is a carbon, and that's lower atomic mass, atomic number than chlorine or bromine, so that's why it comes next. What about this third case? Fourth case here. We have carbon, carbon, hydrogen. Now, if you look at this example here, in the previous one, the one in the lower left has a bromine on it, but we never get to it. The comparison between the top right and the lower left, carbon and carbon is a tie, then carbon and carbon is a tie, then carbon beats hydrogen, and that wins the game. Okay? What happens if all three atoms are a tie? You move to the next atom in the chain and play another 3 rounds and see which wins. Now, if we look at this last example, the lower right, that's a pretty long chain of carbons. And you might look at that and say, oh, that's going to be high priority compared to some of these other ones. But it's not. Because what is on there? Carbon, hydrogen, hydrogen. So it loses out to all the others. Carbon is a tie with carbon for a couple of them. It loses to chlorine and bromine. The second round, hydrogen loses to all the others. So that's the deciding factor. So for example, here we have 2-hexanol. Is this R or S? Well, what are our groups on here? Hydrogen and oxygen. These two are clearly low priority and high priority. But the other two groups, carbon and carbon, that's a tie. So what does this carbon on the left have on it? The first has a hydrogen over here, or I'm sorry, a carbon over here. So it has a carbon and then 2 hydrogens on it. This one has a carbon and 2 hydrogens. Well, that's a tie. So let's go to the next one. What does this have on it? A carbon, the next carbon in the chain, and 2 hydrogens. And this one has hydrogen, hydrogen, hydrogen. It's the last carbon in the chain. There is not another carbon beyond it. So at this point, the decision is made because hydrogen on this loses to carbon on this. That's the end game right there. So this would be 2, and this will be 3. So if you look here, we have 4 is here, 1 is here, 2, and 3. And we're probably going to want to rotate on this axis. So we start with 1 is up here, 2 is here, 4, and 3. We want to rotate so that 4 goes back. And so now we see that this is counterclockwise. So it is S. Now the third rule, which doesn't come up, I give it to you because it might come up in a simple way, but this rule can get a little tricky and complex with some problems. But this being kind of a 1 semester overview course, I won't get too tricky with it. But this deals with multiple bonds. So take this carbon right here. It has, if we had to do a tiebreaker, carbon and a carbon, so which one is higher priority? You look at the 3 groups on the carbons, play the game like we've seen in the previous examples. But now we have a double bond. So you treat that as like 2 bonds to carbon. So you can see here it's like a virtual atom. So the first carbon, this R would be like the chiral center, like this group is on the chiral center, and we're trying to rank it. Is it high priority, low priority, or somewhere in between? So the first carbon here has a carbon, and a hydrogen. And if we had to go to the next one in the chain, which is the other end of the pi bond, This is where it gets tricky. You have C, C, and H. And I say it's tricky because normally you don't look backwards. You move to the next atom, and if it's a carbon, there's 3 things on it. And it's usually hydrogens or the next carbon in the chain, but you don't go back to the carbon you just moved away from earlier in the chain. But you have to when there's a pi bond. So you do include it then. The next example here, the first carbon would have N, N, H. And sometimes you're comparing other, like if you move down a chain, maybe both of them has a nitrogen, but that's where the tiebreaker takes place. Maybe there's different things on the nitrogen. So this second atom is a nitrogen, and what does it have on it? 2 carbons. I'm sorry. 1 carbon, because there's the hydrogen and the bond back to carbon. You can see here the hydrogen and the bond back. There's a lone pair, and you don't use that. So a carbon and a hydrogen. If you're comparing the groups on 2 nitrogens for priority, it would be a 2-handed game, not a 3-handed game. So that's a little different there, but you get the idea. So here we have an example with a double bond in it. 5-methyl 3-nonene. Is it R or S? Well, hydrogen is clearly group 4. We have a methyl, a butyl, and a 4-carbon chain with an alkene in it. So these are carbon, carbon, carbon. It's tie, 3-way tie. Well, what does this carbon have on it? H, H, H. This carbon has a carbon, H, and an H. And this one has 2 carbons. The double bond means it's got 2 carbons. And we can see the priority now. This will be 1, this will be 2, and this will be 3. So if we label these, this is 4, 1, 3, and 2. And it's nice because 4 is going back. We don't have to do any rotation. This will be S.